In this video, we're going to talk about multiplication and division of rational expressions. First, we'll talk about how to multiply fractions of integers before we talk about how to multiply rational expressions. Remember, with fractions, you multiply numerator by numerator and denominator by denominator, and then if there are any common factors, you're able to reduce. If we wanted to multiply 3/7 by 2/5, we would multiply 3 by 2, 7 by 5, and end up with 6/35. If we wanted to multiply 30/7 by 14/10, we could do that, but we could also divide out some common factors and have an easier time reducing our answer. So we could factor 30 into 3 times 10. 7 doesn't simplify. 14 we could factor into 2 times 7. 10 we can leave as is. And now here we have some common factors that we can divide out. These 10s cancel with each other, and the 7s cancel with each other, and we're left with 3 times 2, which is 6. We're going to be doing the same types of things with rational expressions. The only difference is you're going to have to factor numerators and denominators. So how to multiply rational expressions: first, factor the numerator and denominator of each fraction if possible. 2, divide out any common factors. 3, multiply into a single fraction. 4, leave your answer in factored form. Don't do the extra work of distributing and multiplying things out after that. Let's look at some examples now. A, we have 40x cubed over 6y times 15y squared over 5x to the 5th. There's some simplification we can do right away with our coefficients. We see 5 goes into 15 3 times, and we see 6 and 40 both have a common factor of 2. If we divide 40 by 2, we get 20. If we divide 6 by 2, we get 3. So we can start by rewriting these as 20x cubed over 3y times 3y squared over x to the 5th. Now we see we have a common factor of 3 that'll cancel, and we have a common factor of y here, so that'll get rid of the y squared. Then we have x cubed over x to the 5th, so that's going to become an x squared in the denominator. And we're left with 20y over x squared. If we take a look at part B, there aren't immediately any common factors, so all we can do is express our product like this: a plus 5 times a minus 3 divided by a minus 2 times a plus 4, and that's it. There's no common factors to divide out, and we don't need to multiply out any of these factors. Now let's look at some more examples. For C, everything is already factored for us. We'll start by looking for any common factors. Here we have a common factor of h minus 8 that we can divide out. We have a common factor of h minus 6 that we can divide out. And that's it. So we multiply, we end up with h plus 2 times h plus 3 over h minus 2 times h minus 7. And that's it. We cannot simplify this anymore. D is a little bit more work. Here we're going to have to factor our numerators and denominators before we can find common factors. If we look at the first rational expression that we have here, our numerator will factor into n plus 2 times n plus 4, and our denominator will factor into n plus 1 times n plus 2. Now we'll factor the second rational expression. N squared minus 1 is difference of perfect squares, so this will factor into n plus 1 times n minus 1. Then we have n squared plus 8n plus 16, and that's going to factor into n plus 4 times n plus 4. Now we need to look for any common factors that divide out, and then we'll multiply. So we have a common factor of n plus 2. We have a common factor of n plus 4. Then we have a common factor of n plus 1. So in the end, we're left with n minus 1 over n plus 4. Here's another example. I would suggest pausing the video here, try to work through this one on your own, then hit play to see me go through the answer. First thing we would need to do here is factor both numerators, both denominators. If we do that, we end up getting this. Now that we factored everything, we'll see what common terms we can divide out. We have a common factor of x minus 2 that we can divide out. There's an x here, an x squared, so that x squared will go, and that x will go. We have the 2 and the 4, so that'll become 2. 3 and 6, they'll also simplify. 3 will go, 6 is going to become 2. Now we have 2 over 2, they'll cancel, and we'll be left with x minus 3 divided by 2x minus 3. Now, note we can't further simplify x minus 3 over 2x minus 3. It might look like this is something that can cancel, but notice the 2x and the 3 here are separated by subtraction. 2x minus 3 is not the same thing as 2 times x minus 3. If we had this, then we could definitely cancel, but that's not what we have. This is a different thing, so just keep that in mind. Here's one more example. Again, I would suggest pausing the video, try to solve it on your own, then hit play to see me go through the rest of the answer. Again, what we need to do, factor our numerators and denominators, and then simplify from there. So once we factor, we should end up with the following. Remember, x squared minus 16 is difference of perfect squares. Difference of perfect squares is a factoring technique that they like to use a lot in these types of problems. And now we'll factor the second rational expression. Now that we've done this, we can start to divide out any common factors. So we have x minus 4 over x minus 4, x plus 1 over x plus 1. We have an x minus 5, x plus 4, and x plus 4. Turns out everything divides out, so we are just left with 1.